Okay, this is the Chapter 8 test review. Question number 1 has y equals 2x minus 3 over x plus 2. Now this is a non-factoring one. There's no squares or anything common, so you can kind of think of them as being in parentheses already. There's nothing to pull apart, which makes certain parts of it very easy. Horizontal asymptotes. Okay, horizontal asymptotes are based on being bottom heavy or balanced. Because these both have an exponent of 1, this would be balanced. And so for the horizontal asymptote, we use the leading coefficient test. There's a 2x on top, a 1x on bottom, so that'd be 2 over 1, which is equal to 2. If it's 2x over 3x, it'd be 2/3. So wherever that happens to be, there's our horizontal asymptote. Vertical asymptote always comes from what makes the bottom equal to 0, which would be -2. Holes happen if something on top cancels with something on bottom. This is a case where there isn't an x plus 2 on top. So because that doesn't happen, there are none, or you can write NA. The next thing would be domain. The domain is that x cannot be either of these two things, the vertical asymptotes or the holes. So the domain would be not -2. And the last thing we have to find are the x-intercepts, which comes from making the top equal to 0. And we always said if you switch the sign, but then you'll have to divide by the 2. So if you think about 2x minus 3 equals 0, obviously we'd add 3 to get x alone, but then we'd have to divide by 2. Divide by 2, we get 3/2. So there's an x-intercept at 3/2, which is 1.5. Okay, so we go to produce the graph. We're going to throw a few things in. A vertical asymptote over here at -2 would be useful, and then a horizontal asymptote at +2 is also necessary. I'm supposed to cross the x-axis at 1.5, which would be right about there. I'm expecting to cross the x-axis there. Now, I could type this in the calculator, but I already know what this graph's going to look like. But let's go ahead and do it. I'll go to y equals, press alpha y equals. I can get the fraction denominator set up to do the 2x minus 3 over the x plus 2. If you're not using this fraction notation, you're going to have to use a lot of parentheses, and most of you will unfortunately mess up and get it graphed wrong. So we can see there's a graph in the top left and in the bottom right, which I kind of already knew because it had to cross through that point right there. Okay, so try to make sure that when you put those x-intercepts down that you're actually going through them. Just makes the graph a little bit more formal and definitely a lot better. Let's look at question number 2, which has y equals x plus 1 over x squared plus 5x minus 6. And if we factor the bottom, that should happen automatically in our process. 6 splits to subtract to make a 5 would be 6 and 1. To get a +5 here, I'm going to have to use a +6 and a -1. So now that has been factored, it doesn't really exist anymore except for doing our horizontal asymptote test. Because this was x squared over x, with x to the first on top, this would be bottom heavy, and all bottom heavy equations go to 0. For our vertical asymptotes, it's what makes the denominator equal to 0. Now this is important. If something cancels, okay, so for instance, if the top said x minus 1, we would cancel that x minus 1 with the x minus 1 in the bottom, and that wouldn't be a vertical asymptote anymore. That would be a hole. In this case, our vertical asymptotes are at -6 and 1. And again, because nothing cancels top to bottom, there are no holes. I'm not saying that won't happen on the test. It'd be just as easy for me to write this test with an x minus 1 on top, and force you to cancel them and then have a hole at +1 instead of a vertical asymptote. This is just how the test review came out. X cannot be -6 or 1. And then last would be our x-intercepts, which are when the top is equal to 0. That would be at -1. Again, we can produce most of our graph without ever going to the calculator. Over here at -4, 5, 6, I'm going to have a vertical asymptote, and at +1, we'll have a vertical asymptote. Horizontal asymptote right through 0, and we're going to cross the x-axis at -1. I'm going to definitely use my calculator to help with this. In the top, I want to have an x plus 1. On bottom, x squared plus 5x minus 6. If I graph it just for shape, I can see the 3 pieces to it. I can see the bottom left. There's a zigzag that goes through the middle and then top right. So that should give me a graph that looks a lot like this. And let's flip that right there. There we go. So there's our graph with all the information that we stated off to the side beforehand. Okay, now that we're done with the graphs, everything can go a little bit faster, at least for the first part. Number 3 and 4 are basically the same question. We have x squared plus 3x minus 4 over x squared plus 4x plus 4 times 2x plus 4 over x squared minus 4x plus 3. And first thing we're going to do is just go in and start factoring. X and x. The factors of 4 that subtract to 3 would be 4 and 1. To get a positive 3, we need plus 4 and a minus 1. Down here, again, factoring x and x. How do you split a 4 to add up to 4? Would be 2 and 2. Everything's positive, so plus plus. Down here, same thing. Again, x and x. How do you split a 3 to add up to 4? Be 3 and 1. To get a negative 4, you need minus and minus. And then up here, there's no x squared, but there is a common term of 2. And we think of x plus 2. At this point, we're just going to go through and look for cancellations. There is not an x plus 4 in the bottom, so it stays. There is, however, an x minus 1, so it cancels. There is not a 2 that's by itself, so it stays, but there is an x plus 2. Leaving me with, I've got a 2 and an x plus 4 on top. On bottom, I still had an x plus 2, and I still had an x minus 3. And that would be my answer for question number 3. Question number 4, we have x squared plus 12x plus 32 all over 6x plus 42 divided by, which I'm going to switch. If you're looking at your test review, we are making a change right now to multiplication, and we're flipping this to x squared minus 49 over x squared plus 4x. This is backwards. It was an upside down version of this originally. Again, we're just going to go through and factor x and x. Factors of 32 that add up to 12 are 8 and 4. Everything's pluses, so plus and plus. Down here, it's just what they have in common, which is a 6, leaving me with x plus 7. Over here, this is the difference of squares, x and x. The 49 becomes 7 and 7 with a plus and a minus. And the bottom down here, they have an x in common, leaving me with x plus 4. Going through looking for cancellation. X plus 8 doesn't cancel, but x plus 4 does. X plus 7 cancels, but x minus 7 doesn't. So I have x plus 8 times x minus 7 all over 6 and x. If you have questions so far, pause, come back, talk to me. We'll keep going in a second. Okay, question number 5 has 3x over x squared plus 3x plus 2 and 5 over x squared minus 4. And all I want is the LCD. Okay, this is the top doesn't matter at all. I'm just asking you, hey, what's the LCD of these two denominators, these two fractions? So we're going to factor x and x. 2 becomes 2 and 1. Everything's pluses, plus and plus. These are going to be easy to factor. Over here, we've got an x plus 2 and an x minus 2, a difference of squares factor. When we combine them to make the LCD, the only thing we have to remember is that if something shows up in both of them, it only needs to show up once. And so I need an x plus 2 But 1x plus 2 covers both of those. I still have to come up with the x plus 1 and the x minus 2. Question is, could you create this denominator here with this guy and this guy using only multiplication? The answer is yeah. This guy would still need, what, an x minus 2 multiplied, and this guy would need an x plus 1 multiplied. That's an easy production to do. Now, whatever we do at the top, we do the bottom. All you're doing right here, though, is just finding the LCD. It's making sure we understand the premise so that as we go forward with the next, 4 problems, we don't have any issues. Because these last 4 are all about using the LCD. So number 6, we got 3 over x plus 2 minus 2x over x plus 3. First thing that I like to do is find the LCD. Well, first I'm going to change, let me rephrase that. Change that to plus a negative 2x. My LCD would just be x plus 2 times x plus 3. I'm just going to combine the two denominators into one bigger denominator to get at my LCD. In order for the left fraction to have the LCD, I'm going to do an x plus 3 and an x plus 3. Whatever I do to the bottom, I'm going to do the top, x plus 2 and x plus 2. That way both of them have the same denominator. A little distribution gives me 3x plus 9 over x plus 2 times x plus 3 plus negative 2x times that is negative 2x squared minus 4x all over x plus 2, x plus 3, and if I combine like terms, the negative 2x squared doesn't have a like term, but 3x and negative 4x can combine to make negative x, and then I just have plus 9 all over x plus 2, x plus 3. Okay, I want to point something out. Number 6 is the only problem that has the LCD in the answer. Okay, number 7, 8, and 9 are not going to have the LCD in the answer because we're going to eliminate the LCD. So this is really important. When we add or subtract, the LCD shows up in our answer. Any division, multiplication, or solving is not going to have the LCD in our answer. So let's take a look at these last 3. These last 3, 7, 8, 9, are all about cancellation of the LCD. So we have 4 over x plus 2 over x plus 3 over 1 over x plus 3 minus 3 over x. And right away we're going to make that same sign change, plus a negative 3. All right. X plus 3 is going to be its own thing in x, so our LCD should be x times x plus 3. You're going to see a lot of this kind of denominator on our test, on the solutions for our test review here. What we're going to do now is we're going to multiply each of these by our LCD, x times x plus 3 times x plus 3 times x plus 3 times x plus 3. And certain things are going to cancel. In this first fraction, the x cancels the x, and I'm left with 4 times x plus 3, or 4x plus 12. Here, the x plus 3 cancels, and I'm left with the 2 times the x, or plus 2x. All over. Down here, the x plus 3 cancels the x plus 3, I'm left with 1 times x, or 1x. Here, the x cancels the x, and I've got negative 3 times x plus 3, or negative 3x minus 9. If I combine my like terms, I should have 6x plus 12 over negative 2x. Did I get that right? Yeah, negative 2x minus 9. And we're there. Okay. So again, is the LCD in my answer? No. Question number 6, though, I get a lot of people who try to cancel the LCD. Number 6, the LCD needs to show up in your answer. Number 8, we're almost there. 2x minus 3 over x minus 4 equals 5 over x minus 4. I'm going to put some parentheses around these. This is where we have one fraction equal to one fraction. There's just that simple of a problem. We can cross multiply. Well, 2x minus 3 times x minus 4, you have to FOIL. So you get 2x squared minus 8x minus 3x plus 12 equals, this will be a little bit easier, 5 times x, and 5 times negative 4 is 20. Because I have an x squared, I'm going to minus 5x and add 20, minus 5x and add 20 in order to get this equal to 0. This gives me 2x squared minus 8 and 3 is 11 makes 16x plus 32. I notice all these divide by 2, so I'm going to do that to the whole problem just really quickly to clean it up. It creates x squared minus 8x plus 16 equals 0, which factors into x minus 4 and x minus 4, which means the only answer I get is 4. I get it twice, that doesn't matter. I get it once or twice, it doesn't matter. But when I check that answer, that makes the bottom equal to 0, which is bad. So we reject our answer and we have no solution. It's possible that you have a solution. It's possible you have no solution. It's possible that you have 2 answers. It's possible that you have 1 answer. It just depends on the context. Again, you can pause, rewind, all that kind of stuff to get the whole video at your pace. Last question, number 9, just trying to hustle through here. We got x minus 1 over x minus 3 equals 1 over x plus 2 over x minus 3. Again, these x minus 3's are in parentheses, as is that x minus 1. We want to start by finding the LCD, which would be x times x minus 3. That looks very similar to what you saw on question number 7. We're going to multiply, just like we did on number 7, by the LCD, times x minus 3, times x minus 3, times x minus 3. The x minus 3's cancel here, and I distribute an x to get x squared minus x. Here the x cancels, we distribute the 1, well there's an equal sign, to get x minus 3. The x minus 3 cancels here, and we multiply to get plus 2x. I have an x squared in my answer, so I want to move all my x's to the other side, and all my stuff to the other side. This is a minus x, and this is a minus 2x, minus 2x. That'll cancel that and that. I'm going to have to add 3 to get x squared minus 4x, that's all that, plus 3 equals 0. That's a mess. Let's go back real quick. Plus, undo that, 3 equals 0. There we go. And when we go to factor that, x and x, how do you factor a 3 to get a 4? 3 and 1, same signs, I've got to go minus minus. That would leave me with x equals 3 or 1. But when we take the 3 and we plug it in right there, we get 0, which is not okay. So we reject the 3, we keep the 1. That's the whole thing. There's going to be questions, processes. Processes are going to be identical on the test, so come ask your questions and we'll see what we can answer and clear up. All right, good luck.